relaxing self-study week. I know that most of you have assessments this week, so good luck with your assessments. We'll be starting Module 3, obviously, and Module 3 deals with some more tools and methods of operations management. So as usual, I'm going to try to start with the broader context and essentially show how today's topic fits into the overall perspective of managing operations. So to refresh your memories, we started with a general, definition of operations management. We looked at some of the simpler tools and techniques, and if you remember, the common theme to many of those was the analysis of the process, like for instance process requirements, the process time, and so on and so forth. Then we looked at topics that relate to a measure or some determination of various aspects of the overall operations department or the so-called transformation system. And we finished in the last week by having a look at the simulations and so on and so forth. And essentially the idea there is that the management of operations departments and operations management in general, the decisions that are made tend to be rather complex and tend to be interrelated, although we discuss these in a rather independent manner. So where does that bring us, or how does that relate to the topic for today? In line with the overall evaluation of the capacity of a system, you see, in the production department, in operations departments, a primary concern is capacity, because essentially capacity will enable us to meet the demand, which is the primary factor driving the entire organization. So in order to be able to determine the capacity, among the things that we need to determine are, for instance, the time it takes to produce a given unit. We've already given examples before where we said we assume that we know how much time it takes to make one unit of a given product. Then using that, we can determine the capacity requirements in terms of, for instance, the number of people that would be required, in terms of the number of machines, equipment that would be required. In making this decision, the impact is quite significant and has a significant time frame associated with it. What does that mean? Well, it means that if I inaccurately determine the time requirements, okay, for the making of a given product or a service, then the estimation of the capacity of the system will be incorrect. Based on that, the relationship between the capacity and therefore the supply, what we are able to produce, versus the demand will also be, there will be a discrepancy. We'll either be producing more than the demand, in which case we'll be wasting resources, or less than the demand, in which case we'll be losing customers. So to be able to determine the amount of time it takes to make a given unit of a product or a service is critical in making many other decisions that have a longer term and that are of a longer term nature. And that's where today's topic comes into play, which is the idea of learning curves. The idea of learning curves is based on the simple observation, and this is something that all of us can actually relate to, that we as human beings, and this is only applicable to people when we're talking about learning and learning curves, this is applicable to people, obviously. As human beings, as people, we tend to learn over time, and we tend to do things more efficiently over time. What does that mean? Well, it means that if I do or carry out a certain task, for instance, assembling a product or providing the service, the first time I do this, it might take me quite, some time to understand the overall, aspects of the delivery of the service or the making of that product or the assembly of that product. Because the first time I do this, I need to adjust to the settings. Okay, I need to know where everything is. The second time I do this, I already have learned some of the basic, for instance, locations of the equipment. I have learned better how the process works. So most likely it's going to take me less time the second time around. If I do this more and more times, it's going to take me maybe even less and less time, especially when I'm talking about doing the exact same thing over and over, which is very typical in manufacturing settings or even in services. Although in services, it's a little less, standard, because in general you have to deal with people and people are not very standard. But in manufacturing, if I'm assembling a product or if I'm making a component, it's the exact same work that we're doing over and over. All right. So the question of determining the process time per unit is critical, all right? And the learning curve or the learning curve concept deals with this question. How do I determine how much time it's going to take me down the road, down the line, to make a given unit of product? Because you see, if I base my estimation on the time it took me to make the first unit, I will be significantly exaggerating, because as we said, the first time you make the product or you deliver the service, it's gonna take much more time than when you repeat this over and over. All right. So therefore, the learning curve displays the relationship between how much time it takes per unit, for example, in hours or whatever, and the cumulative produced number of units. The cumulative produced, okay, because the reasoning, the idea is that we learn through the accumulation of the production, and it's just like when we talk about the experience, okay, it's the accumulation of the experience. That's how we actually learn. So what remains is, in order to make it a curve, is how do we represent this in a mathematical manner? Because the concept is very straightforward, okay? Everyone can certainly relate to that. You can ask anyone and they will certainly answer you in the same manner. When we repeat the same task over and over, we will certainly become more efficient at it. We will certainly become better at it, and it will take us less time. The question is deciding exactly how much less time, and deciding also at what point does that learning basically stop, or that the effect of that learning becomes very minimal. All right, because that means that at that point, okay, the time is gonna take will pretty much remain fixed, and maybe that's the time that we should use as our standard. And this is exactly what it's saying in the following slide. The learning curve looks like something like this. What does that mean? The time it takes per unit for the first unit and for the first few units is high, and then it drops significantly as we produce more and more units of the product. It drops significantly. You see, it has like a inverse logarithmic shape, if you remember in mathematical terms. Okay, it drops significantly, and then at a certain point in time it becomes fairly stable. Well, what that means is that at this level of production, that's the end of the learning period. After that, the time is pretty much standard, and that's what we call the standard time. We've already seen this term before, the standard time, when we looked at the calculation of the process requirements. This is how we calculate the standard time. This is how we determine the standard time. So this is also a reminder that although we're discussing these, techniques or these tools rather separately, they are all in the end related. So the question now is, how do I determine this curve explicitly? How do I actually mathematically determine the function here between the time it takes per unit versus the cumulative number of units produced? The time as a function of the number that we produce in total, cumulative, not on a period by period basis. Okay, that is the perspective or the objective. All right, before I continue, actually, I just need to tell you that I'm only gonna be with you for about 25 minutes. At 10:30, I have a very important meeting that I have to attend. So we might not finish this now. We're gonna do it, finish it at 1 o'clock, okay? Just to let you know in advance. The learning curve, mathematically, okay, follows what we call a logarithmic model. And the function for the time it takes to produce the nth unit, which we're going to refer to as Kn, is calculated as, or using this formula. Kn is equal to K1 multiplied by n to the power of b. K1 is the time for the first unit. How do we get this? By observation. Okay, the first unit that was produced, that was manufactured, that was assembled, we calculate the direct, and you see this is the direct labor hours, the amount of time that the employees actually put into the making of the product or the service. N is the cumulative number of produced goods, and this is important to keep in mind. We're talking about the cumulative. Okay, so for instance, if I produced 5 in the first period and 10 in the second, the cumulative is 15. So the cumulative from the beginning up to whatever point in time we are at. B, on the other hand, is calculated as the log of R divided by the log of 2. Log is the natural logarithm. Okay, in some calculators and in Excel, instead of log log, you're going to find that it says ln, natural logarithm. Divide by log of 2, and we're going to comment on this divide by log of 2, y2 in particular, where R is a learning rate, and it's a decimal or a percentage. The learning rate is very important in understanding this whole thing. What does the learning rate mean? All right. Now we know what the formula looks like and how to use it, but what does the learning rate mean? Okay, and how do we, maybe determine this in practice? The learning rate gives us an indication of the reduction in the time it takes to produce a given unit every time that the cumulative production is doubled. What does that mean? It means the following. All right, suppose that I have a learning rate of, let's say, 0.6, 60%. Okay. What does this number mean? This number means the following. For the first unit, okay, suppose that for the first unit, the time it takes, which is K1, let's say it was 100 hours. Okay. So suppose that was 100 hours for the first unit. For the second unit, okay, what this means is the following. Because now we have doubled the production. 2 is 1 times 2. Double the production. Then the time it takes is R multiplied by K1. This is what the learning rate means. Every time we double the production, the cumulative production, the time it takes becomes that fixed proportion of the time it took in the previous level of production. So in this case, it will be 0.6 times 100, which is 60 hours. Okay. How about for unit 3, the third unit? Well, we cannot do this using just the learning rate. If I'm talking about the third unit, then I must use the formula, which is K1 or Kn is K1 times n to the power of b. The learning rate applies to every time that the production is doubled. So therefore, this will be for the fourth unit. Why is that? Because 2 times 2 is 4. It's doubled. Then in this case, the learning rate will be R times K2. So it's going to be 0.6 times 60, which is 36 hours. All right. This is what the learning rate means. Okay. Every time that the production is doubled means times 2. The time it takes drops by a fixed percentage, which is the learning rate. So the next one, if I want to find the next one, which unit would I look for? So what would be the next one in order to use this?
Unit
R
6.
times K4. Very good attempt, but think about it. We said it's doubled. When it's doubled, 1, 2, 2 times 2 is 4, then 4 times 2 is
8.
8, correct? Every time that it is doubled. That's how the learning rate is interpreted. So the learning rate is every time that the cumulative is doubled. That's how we use it. All right. So I hope that this is clear, because you see, using the learning rate, I can actually find the time for the second unit, for the fourth unit, for the 8th unit, without using this formula here, just using the meaning of the learning rate. Okay. So the idea is exactly that. The other thing now is, as I said earlier, the log 2. Why 2 in here? Well, simply because of what we just said, that we're looking at every time that the production cumulative is doubled. You see, that's why we are using the log of 2 and not the log of 3 or 5 or 6. The doubling of the production, of the cumulative production, leads to a learning and a reduction in the time it takes by a certain fixed percentage. Now, obviously, at a certain point, as we have already seen in this graph, at a certain point, the curve will kind of become flat, which means that the time from, one cumulative to the double of it will be almost the same. There will be very minimal difference, and that's what we get as our standard time. Okay, so now how do I determine this? Well, we can actually find out. At one point in time, the overall reduction in the time becomes minimal, and that gives us the standard time. Okay. Like, for instance, if I take the example I had here, okay, I have K1 of 100 and R of 0.6. And remember that that's all you need for the formula. The formula is entirely defined by K1 and by R. If I know the time for the first unit and I know R, then I know the time it takes for every individual unit. So let's see how this looks like. For instance, suppose I have here, okay, K1 and R, which is 0.6. That's my example here, K1 and R. We want to find out, when does the learning stop? So let's say, let's look at N and Kn. N is the cumulative units, and Kn, I'm just going to apply the formula. So I'm going to use any number, for instance, up to 100. Okay, I will show you this later in a little bit more detail so that you can see. Kn, according to the formula, all right, it is K1 multiplied by, so it is equal to K1 multiplied by N is K1 multiplied by N to the power of log R by log 2. So log is logarithm ln, R is right there, divided by log of 2. We're going to copy it down and we're going to see how this looks like. We can actually plot this. Okay. Looks something like this. Now the question is, where does the learning stop? Okay. Well, here we have to actually, you can see that, as we do this over and over, there will always be a minor reduction. But where do we start seeing that the reduction is becoming very, very minimal? Like, for instance, we're talking about, starting with 100 hours, okay? And, we're getting here to where the difference goes from 40 to 16 to just 8, and it becomes a difference of only, 1 unit, maybe starting from somewhere around unit 10. We can make actually a stopping criteria and, decide to use that as a standard time. That's one observation, okay? So in terms of determining how it looks like, how the curve looks like, and also from that determining a standard time, or determining the time where the learning stops, the end of the learning period, and the continuation or the determination of the standard time. Okay. The other thing is that you see the values that we have calculated earlier. We are using now this formula. However, the values we obtained for 2, for 4, are exactly what we obtained here by using R times the time of the previous cumulative level. 2, 60. 4, 36. This is exactly what we have here. Okay, 60, 36 for 4. Although we have used exactly the same formula that we have here, okay, versus using R times K in this example here. Okay. All right, before we move any further, as I told you, I have a meeting in about 5 minutes, so we'll finish this lecture at 1 o'clock when we meet again for the second half. But are there any quick questions before we stop here? We'll continue at 1 o'clock, look at the exercises and look at the practice exercise and talk more about how we actually do this. Are there any questions? No?
No, thank you.
All right. Okay, then we'll see you at 1 o'clock. Okay.